Why slow? Okay, Assalamualaikum and a very good evening to our lecturer, Puan Shaliza. Today we are going to present presentation assignment 1. In this presentation, we would like to present about sustainable development process description and selection, mass and energy balance calculation, and lastly, job advertisement.
First, sustainable development process that takes into account the impact of the following pillars to the proposed plan are environment, social, and economic. Environment, energy, electricity, and water. Methanol production process consumes vast amounts of energy and water. Influence of electricity sources and catalyst type of production of methanol. Global warming. The lowest global warming impact was from co-production of methanol and renewable corn ethanol. Methanol are very harmful for human consumption because it is flammable liquid with faintly sweet, pungent odors similar to ethyl alcohol, explosive and poisonous to humans. Methanol is highly toxic for humans if inhaled or absorbed orally and can lead to blindness and, in worst case, even to death. Methanol may affect animals, birds, and fish, leading to their death. Exposure can also cause slow growth rate in plants. Long-term methanol exposure can affect the fertility to biota and affect their appearance or behavior. Next, social risk and hazard to public safety. Leak leak or rupture, shipping accident, vessel collision, risk to public safety, property damage to complex equipment and adjacent plants. Transport and traffic. Disruptive to existing traffic flows, shift changes, transport of construction materials, increased traffic from cumulative industries, increased potential of accidents. Accommodation, the lack of available development land and established houses provide or rent will have an impact on the building and operational workforce. Rental costs in the region will rise as a result of population expansion induced by other proposed projects. Next, service and facility requirement. With a growing population, existing facilities and services such as medical and health services, emergency services, educational facilities, and recreational facilities may be pushed to meet demand. Next, I will pass to Aisha.
Okay, then the economic. Commodity pricing risks. The economic viability of small-scale methanol plants depends heavily on natural gas feedstock and methanol product pricing. High volatility or commodity price beyond this assumed in this analysis present in the report should be carefully evaluated for impact on cost and economy. Next, technology risks. A number of companies are developing small-scale methanol technologies, but none of them has deployed a commercial plants. Methanol production is mature at larger scale. Small-scale methanol may pose unknown or unaccepted risks, mainly because existing technologies have not been scaled up to commercial level as of the time of publications. Careful evaluations of technical viability with emphasis on scale-up risks should be conducted before investing in small-scale methanol plants. Next, capital cost risks. Given the lack of commercially operating plants, capital costs of small-scale methanol plants were assumed for the economic analysis in this report. These capital costs should be verified and validated through careful cost estimation and planning. And last one is market and competitive risks. Methanol demands and supply should be monitored carefully for implications on small-scale methanol plants. The scale of some these companies would allow them to discount transportation costs and provide significant competition in the markets. Next is feasible suggestions. To reduce expense, the process of methanol need to use simpler and less costly syngas cleaning system based on a zinc bed, carbon filter, and zeolite membrane. Next, form a partnership with community members to prepare a suitable housing plan for the construction and operation crew. New plant should be designed using best practicable engineering design and operated using best industry practice management system. Plant proposal that not harmful to human, environment and animal. To reduce environment impact, renewable energy should be used instead of coal and nuclear energy. To control global warming, the production of greenhouse gases must be kept in approximate balance. Next, I will pass to task 2.
Next, we are going to discuss about the process description and selection. So, there are 5 processes available in the methanol processing industry. The first one is methanol production synthesis gas via carbon dioxide hydrogenation. The second one is methanol production by catalytic reduction of carbon dioxide using copper and palladium as catalysts. The third one is methanol production via catalytic coal gasification. The fourth one is methanol production and aerobic digestion from squander stream. And the last one is methanol production via methanotrophic bacteria methyl acidophilum fumarioleucum. So the description for the first process is methanol production synthesis gas via carbon dioxide hydrogenation. Methanol is manufactured conventionally from petroleum product synthesis gas via hydrogenation of carbon monoxide and carbon dioxide, as well as a reverse water gas shift process. Methanol is an important industrial chemical as well as a versatile fuel. Majority of methanol is produced via catalytic conversion of synthesis gas, which is typically produced by stream reforming natural gas. At temperature of 200 to 300 degrees Celsius and pressure of 50 to 100 bar, syngas, a combination of hydrogen, carbon monoxide, and carbon dioxide, is transformed to methanol using copper and zinc oxide-based catalysts. Next is methanol production by catalytic reduction of carbon dioxide using copper and palladium as catalysts. Utilization of carbon dioxide as the carbon source in hydrogen-based processes where the hydrogen created from water using renewable energy and the reaction produce methanol. This will aid in the reduction of carbon dioxide emission and the reduction of reliance on fossil fuels. Using nanoparticles of the catalyst dispersed on a porous support material that improve the surface area of the catalyst, mixing palladium and copper give the most efficient conversion of methanol from carbon dioxide in the atomic ratio range of 0.3 to 0.4.
One of the process to produce methanol is via catalytic coal gasification. Gasification of coal is to produce synthesis gas, which is carbon monoxide and also hydrogen, is followed by catalytic conversion to manufacture methanol. The process name is methanol from coal process. Coal gasification is a process that transforms carbonaceous materials into carbon monoxide and also hydrogen, such as coal, petroleum, petroleum coke, or biomass. Coal gasification is growing in popularity as a power generation machinery due to the readily available raw material around the world, as well as the beneficial environmental concerns associated with the machinery over other combustion machineries. Most of the methanol industry's progress in the early 21st century, the third golden age of methanol expansion was fueled by China's rising economy. China's petrochemical industry had been heavily reliant on imported crude oil, despite the country's abundant supply of low-cost coal. China began to adopt innovative technology for converting coal into various chemicals, and methanol was a significant component in that process. Next is methanol production via anaerobic digestion from squander stream. Anaerobic digestion is a process in which microbes break down organic matter in the absence of oxygen. Anaerobic digestion is a low-energy, technologically easy method for converting organic material from a variety of wastewater types, solid waste, and biomass into methane. Anaerobic digestion for biogas generation occurs in a sealed vessel known as a reactor, which can be designed and built in a variety of forms and sizes depending on the site and feedstock circumstances. Biogas production can employ a variety of waste kinds as feedstock. Agricultural leftovers, paper trash, food waste, livestock manure, and sludge from water resource recovery operations are the examples of feedstock. Biogas and digested are two useful byproducts of anaerobic digestion. Methane, the major component of natural gas, accounts for 50 to 75% of biogas, along with carbon dioxide, hydrogen sulfide, water vapor, and trace amounts of other gases. Next is the methanol production via methanotrophic bacteria, methyl acidophilum fumariolicum. Modern methanol creation changes over methane from gaseous petrol into methanol through a multi-step compound interaction. Natural methane to methanol to change under moderate conditions, and utilizing biogas would be even more harmless to the ecosystem. Methanotrophs, which is a microorganisms that utilize methane as an energy source, convert methane into methanol in a solitary advance, catalyzed by the compound methane monooxygenase yet hydrase of methanol dehydrogenase, which catalyzes the ensuing transformation of methanol into formaldehyde, is a significant task. Methanol dehydrogenase is required by aerobic methanotrophs, which is a bacteria that oxidize methane for carbon and energy to convert methanol to formaldehyde. In this review, we utilize the thermoacidophilic methanotroph, which is methyl acidophilum fumariolicum, solvent for natural methanol creation. Next is the merits and demerits of each process.
Okay, so for merits and demerits of each process. The first one is methanol production, synthesis gas via carbon dioxide hydrogenation. The merits are carbon dioxide can be used directly, act as feedstock to supply useful chemicals and materials, reduction of carbon dioxide quantity, and it also low cost. The demerits are one of every greenhouse gas which may cause heating, reversible reaction and formation of greenhouse gas also may occur. The next one is methanol production by catalytic reduction of carbon dioxide using copper and palladium as catalysts. The merits are reduced carbon dioxide emissions, reaction conditions are milder due to less exothermic reactions, methanol can be produced in high selectivity at an efficient rate. The demerits are less reactive than syngas, then led to larger reactor being needed. More water is produced due to the reverse water gas shift reaction, higher carbon dioxide partial pressure, and more carbon dioxide produced in crude methanol.
Now let's review the merits and demerits of methanol production via catalytic coal gasification. The merits are low cost, availability and distribution are large and less susceptible to political pressures. The demerits are coal can be hazardous to the environment because of the greenhouse effects caused by carbon dioxide emissions. And the last demerits is severe regulations limiting its release into the atmosphere have reignited interest in sulfur chemistry modeling because hydrogen sulfide is a common byproduct of coal gasification. Next is the methanol production of anaerobic digestion from squander stream. The merits and demerits are converts sewage into renewable technology, creates a more environmentally friendly gasoline, and removes germs that are dangerous to humans from biological waste. Fertilizer is manufactured, and last one is it helps us to lower our carbon footprint. The demerits are it does not convert quite as much carbon from biomass to biogas as gasification does. And last one is methane producing organisms develop at a slower rate than aerobic species. Last one is the merits and demerits of methanol production via methanotrophic bacteria, methyl acidophilum fumarolicum. The merits are low cost, efficient methane liquefaction model, and the demerits are difficulties at high cell densities, cell development processes that are biphasic, and chemical methanol dehydrogenase inhibitors, which can also inhibit other important enzymes, are used to increase methane conversion.
Okay, next we are going to discuss about the process block diagram, process description, process flow diagram, PFD, reaction stoichiometry, and supply of raw material. Okay, basically this is the figure 1 shows block flow diagram, BFD for methanol process. The block diagram explains the way in which methanol are produced for the industry. Overall, the process consists of 5 stages, beginning with the raw material, which is syngas, and ending up with the product inspection, which is methanol. The methanol production process is a typical loop process. First of all, syngas are collected to serve as a raw material for methanol production. After that, the syngas is developed into methanol reactor and then separate in separator. The separation of syngas is then transferred the raw material to undergo off-gas separation. Gas separation is a technique used to split up gases either to separate and purify multiple or single gas components. Then the products of off-gas separation is either being recycled back into methanol reactor or direct to methanol distillation process to produce methanol. Next is process description. For methanol production synthesis gas via carbon dioxide hydrogenation. Methanol is often created from synthesis gas via hydrogenation of carbon monoxide and carbon dioxide and a reverse water gas shift process in industrial application. Syngas is made up of a mixture of carbon monoxide, carbon dioxide, and many more. The specific temperature and specific pressure are ideal operating parameters for this operation because it is already active at 200 degrees Celsius and selective toward the production of carbon dioxide and hydrogen. Copper and zinc-based catalysts are widely utilized in this process. Natural gas reforming to produce syngas, conversion of syngas to crude methanol and distillation crude methanol are the three basic phases in the manufacturing of methanol. Exothermic hydrogenation of carbon monoxide and carbon dioxide is represented by equation 1 and 2, whereas the water-gas shift process is represented by equation 3. Because methanol synthesis from syngas is very exothermic, it is essential that the reactor vessel be fitted with a heat removal system. So these are the three chemical reactions going on.
The methanol process flow diagram is shown in figure 1.1. The compressor block was used to compress upgraded syngas from the water gas shift reactor. The compressor's design was outside the scope of this research. We employed an we employed an isentropic efficiency of 85% and a mechanical efficiency of 98%. For methanol production, compressed syngas was warmed to 220 degrees Celsius. The vapors that exited the reactor were cooled. The separator or flash drum was used to remove unreacted gases from methanol. The unreacted vapors were recycled in part while the remainder was burned. The separator was used to distill liquid methanol from the flash drum. Methanol distillation of gases were recycled as a separate product. Half of the pure methanol was collected. At the stream 1, we can see that the temperature is 25 degrees Celsius and the pressure is 10 bar. For the second stream, the temperature is 25 and the pressure is 70 bar. For the third stream, the temperature is 220 degrees Celsius and the pressure is 96 bar. For the fourth stream, the temperature is 252.5 degrees Celsius and the pressure is 95. For the fifth stream, the pressure is 110 degrees Celsius and the pressure is 14 bar. For the sixth stream, the temperature is 25 degrees Celsius and the pressure is 10 bar. For the seventh stream, we can see that the temperature is 206.3 degrees Celsius and the pressure is 10 bar. For the eighth stream, the temperature is 90 degrees Celsius and the pressure is 10 bar. For the ninth stream, the temperature is 25 degrees Celsius and the pressure is 10 bar. For the 10th stream, the temperature is 143.7 degrees Celsius and the pressure is 11 bar. For the 11th stream, the temperature is 138.6 degrees Celsius and the pressure is 11 bar. And for the last one, which is the 12th stream, the temperature is 178.6 degrees Celsius and the pressure is 11 bar. Next is the supply of raw materials. The first one is syngas. Carbon dioxide, carbon monoxide, hydrogen, methane, and nitrogen make up syngas. Syngas can be made from a variety of sources, including natural gas, coal, biomass, and petroleum distillate using a thermochemical process. The next one is copper-based catalyst. Copper-based catalyst achieved by mixing metal oxide with copper oxide in a series of steps. To begin, prepare a slurry solution containing catalyzed precipitate by combining an acidic metal salt solution with precipitant solution. The precipitate is then rinsed in a slurry solution, maintaining the suspended condition. And the last raw material is zinc-based catalyst. This catalyst is synthesized by co-precipitating a solution of sodium carbonate with a solution mixture of equivalent metal nitrates that aging it in the mother liquor drying it, calcining it, and reducing it.
Next, 5 utilities and the importance of utilities and other support system. The first one is cooling water. The function of cooling water is to remove heat from component or processes. Process fluid or equipment result in a rise temperature or change of state in the cooling system. The importance of cooling water is to cool processes and equipment in a closed recirculation system. Water containing heat transfer is cooled for reuse and the water loss is small. The second one is steam or condensate system. Steam refers to the white mist that condenses above the boiling water as the hot vapor mixes with the cooler air. The steam has been condensed back into the water by either raising its pressure or lowering its temperature. Steam vapor releases the latent energy to the process fluid and condenses to a liquid condensate. The third one is plant air. The function of plant air are to assure a system quality, usually by sensing, controlling, recording, and maintaining desired operating conditions. It is essential for modern processing, and the instrument will tell the operator what is happening inside a vessel or pipe. The fourth one is electricity system. The electricity generation is divided into two regimes, which are ordinary regime generation and special regime generation, which are to obtain the requisite license and approvals. Last, the operation of the electricity market is to operate on a free market basis and integrate into the functioning of any organized electricity market. The last one is flare system. Flare systems are multiplied to preserve the open flame far from the floor stage and decrease the outcome of heat, smoke, and noise. Some data display that extra than 140 billion cubic meters of herbal fuel line are flared annually. The flaring of herbal fuel line international within inside the oil and fuel line enterprise produce 400 million tons of greenhouse fuel line emissions.
Five main process equipments and the working principle of those equipments and conditions. The first one is heat exchanger. There are four types of heat exchangers, and one and commonly used is the shell and tube heat exchanger. Each one is employed in a unique method to recover heat from exhaust steam by heating the feed water that circulates throughout the units. From the turbine gland steam system, the gland steam condenser gathers steam, vapor, and also air. The steam is condensed and then there are returns and the returns are cooled by the flowing feed water. Next is reactor. Catalyzed filling is cooled and maintained at optimum operating temperature through steam production in the pipe interior. Isothermal conditions were used to run the reactors because of the heat emitted by exothermic reactions can cause considerable and undesired temperature gradients inside the reactors, resulting in catalyzed deactivation. The next one is valve, the controlling equipment for the operation of compressors and for the safety of the entire plant. Almost all pressure measuring instruments work in conjunction with a valve or a combination of valves. Therefore, the needle valve, the valve manifold, or the monoflange marks in a way that unintentional leakage of components, liquid or gas is prevented in the event of an increase in pressure. Next is the distillation column. The distillation column is made up of a series of stacked plates. The liquid flows over the plates and vapor bubbles up through the liquid via holes in the plates. Due to the many plates, vapor comes into touch with the liquid several times as it moves down the column. It is a crucial part in the distillation columns. And the last one is the compressors. Compressors work by increasing the pressure of a fluid while lowering its volume, which improves the energy efficiency. By raising the velocity of the air with a spinning element, the compressor imparts kinetic energy into the air stream. which is then converted into potential energy in the form of pressure. The air is then cooled and excess moisture is eliminated between each step of compression to improve efficiency and also air quality.
Moving on to task 3, which are the calculation of mass balance and energy balance. I will be presenting on mass balance, and for the energy balance will be presented by Muhammad Aiman. There are 5 stages we will go through. Before I present each stage, mass balance is when the value of mass in is same as the value of mass out. So the first one is methanol reactor. This is used to react hydrogen with the carbon monoxide and carbon dioxide in the synthesis gas to produce methanol. The mass flow of outlet methanol is set to be 6,518.886 kg per hour. With that value, we can divide it with the basis methanol at outlet to get the scale up factor value, which is 7.4309. With this factor, we can times it with inlet basis or outlet basis to get mass flow rate of component. To find inlet or outlet actual, we can use the value of mass flow rate and divide it with molar mass of component. Therefore, the mass flow at stream 3 is equivalent to mass flow at stream 4, which is 104,336.6 kg per hour. Moving on to separator. In this process, not 100% of the component will undergo further processing because some will go to recycle pathways. That is why there are 2 outlet streams, which are stream 6 for the component undergo recycling and stream 8 for further process. The composition component of stream 6 is taken from a journal as our references. To find the mass flow rate outlet of stream 8, we can do a mathematical calculation, which are the mass flow of stream 5 minus mass flow of stream 6. Therefore, we can get the total of mass flow rate stream 5 is equivalent to mass flow rate stream 6 plus stream 8. The composition component of stream 8 can be found by using a formula of mass flow rate of component divided by total mass flow rate of stream 8. Next. Thirdly, of gas separation. In this process, it only involves the separation of gas component and non-gas component. Stream 8 is inlet stream, while stream 9 and stream 10 is outlet stream. There is no mathematical calculation needed since it's only the separation gas process. Therefore, the total mass flow rate of stream 8 is equivalent to mass flow rate stream 9 plus 10 composition component. Composition component for stream 9 and 10 can be found by using the formula as shown at the slide. Moving on to the fourth one, which is methanol distillation. In this process, it involves the production of methanol at stream 11 and wastewater at stream 12. Since the demand in producing methanol is 4,563.7544 kg per hour, therefore the purity of methanol can be assumed to be 99.5%. The composition for methanol at stream 11 is set to be 0.995 and for water is 0.005. To find the mass flow rate at stream 12, perform a mathematical calculation where mass flow at stream 10 minus mass flow at stream 11 to get mass flow at stream 12. Therefore, the total mass flow at stream 10 is equivalent to mass flow at stream 11 plus stream 12. Lastly, mass balance on mixing point. Stream 6 and stream 9 is from the separator and off-gas separation respectively. The stream 7 is the pathway to the recycling component process. Therefore, to find the mass flow rate of each component in stream 7 is by adding the mass flow rate of component in stream 6 and mass flow rate of component in stream 9. The composition component for stream 7 can be found by using the formula as shown at the slide. That's all from me. I pass to Muhammad Aiman.
Can you guys see my slide?
Yes.
Sorry, okay, so for energy balance, first before we calculate the energy balance, we need to list some assumptions. The assumptions are potential, and we assume that potential energy is equal to 0, kinetic energy equal to 0, there is no heat loss in the system, Q equal to 0, there is no leakage in the system, change in pressure is ideal gas, therefore delta P is equal to 0. For reference point, we have 3 reference points. It depends on the equipment in the system. Firstly, as you can see that the first reference point have all the components. Is applicable to all the equipment except for separator, gas separator, and methanol distillation. For the second reference point, as you can see that is quite similar to the first one, but what is the difference is the state of matter for water and methanol, which is in liquid. So is the reference point is used for separator and gas separator. Lastly, there are 2 components, which is water and methanol in liquid state at 11 bar and 143.7 degrees Celsius at methanol distillation. So the list of formula that we use for the energy calculation are, first, delta T, which is change in temperature, is equal to integrates from temperature reference to temperature, CP dt. CP stand for heat capacity constant. Next, Q is which is heat in the system equals to summation of heat out minus summation of heat in. Second, H is equal to delta T plus delta P. As you can see the previous slide, we assume delta P is either gas. So we can neglect the delta P, which is 0. Secondly, next, H is equal to delta HF plus delta T plus delta P. Why there is delta HF? Delta HF stands for heat of formation. So for this formula is used for the equipment in reactor. Lastly, for specific volume is equal to 1.013 times 10 to the power of -4 times molecular weight times with change in pressure divided by specific gravity. Next, as you can see in the slide, there are 4 tables which is this of constant. Firstly, heat of formation, boiling point, and heat of vaporization, specific heat capacity, and lastly specific volume V. Heat of formation, boiling point, and specific heat capacity, the data are obtained in the elementary principle chemical process book. So we move on to the first equipment, which is heater. As you know that to find the heat in the system, which in the equipment, so we know that summation of heat out minus summation of heat in. So for inlet, inlet is stream 2 and outlet is stream 3. So as you can see in the yellow that I show this, this is the total energy for stream 2, and stream 3 is 4.96 times 10 to the power of 7. So we can use the formula and we get 4.96 times 10 power of 7 kilojoule per hour. Since it's related to energy balance, so we can actually calculate the power, which is from the energy we use this formula, we actually divided by 3600. So and we get the value of the power, which is 1.38 times 10 to the power of 4. Proceed to the next equipment, reactor. So as I said earlier, in the reactor, we need to add additional heat, which is heat of formation. And we in this table, we add also the temperature reference and temperature to get the value of H. And we get the heat in the system as follow. And the total for inlet, which is as stream 3, is equal to negative 3.38 times 10 to the power of 7. For stream 4, same as stream 3, and we get negative 1.51 times 10 to the power of 8. And we get the heat for this equipment is negative 3.27 times 10 to the power of 4 kilowatt. Next, for cooler have 2 streams, which are stream 4 and stream 5. Stream 4 and stream 5. So stream 4 as inlet, stream 5 as outlet. So for inlet, we get 5.8 times 10 to the power of 7. While stream 5, we get 2.53 times 10 to the power of 7. So to find the heat exerted on this equipment, out minus in, and we get negative 0.327 times 10 to the power of 7 and convert to watt, and we get negative 9.08 times 10 to the power of 3 kilowatt. For the next equipment, separator. So as you can see in this diagram, there are they have 3 streams. Stream 5, tak nak. Stream 5, stream 6 and stream 7 is. So for stream 5 as the inlet, we get the total is 3.83 times 10 to the power of 7. For stream 6 and stream 8, actually for outlet. So we get the total is 2.53 times 10 to the power of 3 and 7.26 times 10 to the power of 6. So in order to find the heat in the system, heat out minus heat in, and we get negative 2.6 times 10 to the power of 7 kilojoule per hour, and convert to watt, and we get negative 7.24 times 10 to the power of 3 kilowatt. Moving on to next equipment, which is gas separator. Gas separator also have 3 streams. Stream 8, stream 9, stream 10. So for stream 8 as inlet, and we get the value of 7.26 times 10 to the power of 5. For outlet, which are stream 9 and stream 10. As you can see, as stream 9, we get 0 total because of the temperature reference is same to the temperature in the system, which is 25. So when we integrate for the same limit, and we get 0. So for stream 10, we add some column, which is boiling point and heat of vaporization. Because for stream 10, there are some component that change its phase, which is, if I'm not mistaken, water and methanol. So we need to consider the value. So and we get the total, the value that I bold this, and we get 6.22 times 10 to the power of 6. To find the heat in for this equipment, out minus in as usual, and we get negative 1.04 times 10 to the power of 6 kilojoule, and to convert kilowatt, same, but divided by 3600, and we get negative 2.88 times 10 to the power of 2 kilowatt. For mixing point, you can see there are 3 streams. For inlet, which are stream 9 and stream 6. For total of in stream 9, the total is 0 because the value we get from the earlier slide. For stream 6, also same temperature. The temperature in the system is same as the temperature reference. So that's why we get 0. For outlet, which is stream 7, the temperature reference is 25 degrees Celsius and the temperature in the system is 206 degrees Celsius. And we get the total for stream 7 is 3.74 times 10 to the power of 7 kilojoule per hour. So in order to find the heat in the system, in the equipment, sorry. So as you can see in the red one, and we get the total is 3.74 times 10 to the power of 7 kilojoule per hour. And the power is 1.04 times 10 to the power of 4 kilowatt. Last but not least, methanol distillation. So methanol distillation have 3 streams, stream 10, 11, and 12. For inlet, there is 1 stream and 2 streams for outlet. So for stream 10, the the value is 0 because as you remember that the earlier slide, we assume for the methanol distillation to be 11 bar at 143.7 degrees Celsius. So it is same with the system. So when the temperature is same as the reference, so when we calculate if we get 0. So for stream 11 there are two columns we add, which is boiling point and heat of vaporization. So and we get the total energy for stream 11 is 2.53 times 10 to the power of 6. And lastly, stream 12. We get total is 2.57 times 10 to the power of 5. So to find the heat in the methanol distillation, we use the same formula and we get 2.79 times 10 to the power of 6 kilojoule per hour. To convert power, we get 7.75 times 10 to the power of 2 kilowatt. That's all for me. Thank you.
Okay, let's move to the job advertisement for 10 working positions. Okay, there are 5 general requirements, which is the first one is the person should have a good communication skill, especially when communicate or dealing with someone about the business. And the second is good command of Mandarin, English, and Bahasa Malaysia. The third one is good analytical, problem solving, and strong interpersonal skill. And next, have a proficient in Microsoft Office. And lastly, of course, he or she should be able to work in team. Okay, so the first position is risk and safety engineer. So risk and safety engineer is they should make sure the workplace are safe, and they also should monitor the general work environment, inspect the building and
Kejelas
mach-
minit.
and machine and recommend safety features in
Yeah,
new
oh yeah.
process and product. Okay, so for the risk and safety engineer, the expected salary is around 2,400 to 4,500 per month,
Teman-teman dah
and the
siap
qualification
tanya
should have minimum have undergraduated in chemical engineering or equivalent, and
jelas ni.
he or she should have a good basic programming skill and must have ability to manage project workload. And the
Sekali.
second position is Aiman of my.
Oh,
Okay, so
sorry.
for the second,
Sorry.
okay, so for the second position is process engineer. So the process engineer is involved with to help to transform the raw material into valuable product, and they are also responsible for designing, implementing, controlling, and optimizing the industrial process and machinery in the manufacturing industry. Expected salary for this position is around RM 3,800 to 5,000 per month, and with a minimum qualification to have undergraduate or postgraduate with a minimum 3 to 6 years of working experience in a methanol processing industry. And the person should have excellent in technical skill and excellent in CAD and AutoCAD skill. Okay, the third position is maintenance engineer. So the maintenance engineer is involved with the checking, repairing, and servicing the machinery. Other than that, the maintenance engineer also ensure the industrial machinery and equipment run smoothly and reliable to use. Expected salary for this position is around RM 3,200 to 5,000 per month, and with a minimum qualification undergraduated with 3 years working experience in this field, and he or she should have possessed knowledge of good current manufacturing practice, have possessed with the knowledge to execute the validation protocols, possess the knowledge in Lean Six Sigma, process improvement, and cost saving. So Lean Six Sigma is a protocol or principle that used in company or other organization in order to improve the capability of their business process. And next is ability to lead and manage cross-functional team and capability to design, install, manage, and maintain the equipment that used for plant engineering system. Okay, for the next position is environment engineer. Environment engineer is involved to research the environmental issues in the area and create the plans to decrease the effect of that problem on the environment. And the expected salary for environment engineer is around 2,500 to 4,500 per month. And with a qualification undergraduate or postgraduate with a minimum 2 to 3 years working experience. And the person should have a good knowledge in ISO 14001 or experience in managed internal and external audit. So ISO 14001 can be known as the effective criteria for an environment management system for some company. And should have competence in schedule waste, excellent written communication and proficiency in reports, and also familiar with the local and international environmental that related to the regulation and standards. And next position is project engineer. So the project engineer is work to plan the project, coordinate the project reviews, and ensure the proper implementation of project element. And project engineer also supervise the technical staff in engineering project in order to ensure the project is complete according to the schedule. And the expected salary for this position is around RM 2,500 to 3,500 per month. And with the minimum qualification to have bachelor degrees in chemical engineering with 2 to 3 years experience in a relevant field, and also have a good knowledge about 3D drawing and modeling, and have a and excellent in AutoCAD skill is a must. Okay, next I pass to the Nurhafiza.
Okay, for the next position that we needed is the utility engineer, or more specific, a boilerman. The expected salary for this position is between 2,400 to 3,400 ringgit Malaysia per month. And we specifically want undergraduate in chemical engineering to take this position. As you can see in the slide, we already marked a few additional skill or additional point which will provide a brighter opportunity to get this position in our company. As example, they must have at least 2 to 5 years experience in process operation and maintenance of boiler. Other than that, they also need experience and hands-on technician and process boiler certificate grade 1 2. For the next one is a quality control engineer, which is in charge of ensuring the quality of all products in multitude of industries. The expected salary is around 3,000 to 5,000 per month. And for this job, we focus more on postgraduate of chemical engineering. Same goes as utility engineer. We also had added a few extra skills that needed for this position, such as they must know basic knowledge on quality principle and familiar with ISO 9001 and ISO 14001 implementation. Other than that, they also must have experience in quality and environmental management system and able to work in a manufacturing process to understand the current process limitation and propose new solution under minimum supervision. For the next job position that we want to highlight is a senior planning engineer with expected salary between 6,000 to 8,000 ringgit Malaysia per month. For this position, we open to both postgraduate and undergraduate to apply, also with other requirements that they should need to get this job, which are They must have knowledge in requirement analysis, project management and safety management, and also process technical understanding, documentation skills, and supervision skill. Other than that, we also need production engineer in our company, and we welcome postgraduate and undergraduate in chemical engineering with expected salary between 3,500 to 4,500 ringgit Malaysia. For this job, both applier must possess knowledge in the field of methanol plant or similar field and have a strong administration skill in planning, organizing, coordination, and documentation. For the last position that we need in our methanol plant company is sales engineer with expected salary around 2,500 to 3,000 ringgit Malaysia per month. We also open this job opportunity for both undergraduate and postgraduate that have experience in methanol industry. This position also needs someone that excellent in sales and result oriented and good at demonstrate and presenting product to client. Alright, the last one is this is our company number, official website, and our email address that can be used to send the resume if interested to working in our company. So that's all from us. Thank you. Okay.
Siapa yang record?